Question says that in the diagram OA, BC, DE, FG is a cuboid in which OA equals 3 units. Let me write that down. OC is 2 units and OD is 2 units. Unit vectors I, J, K are parallel to OA, OC, OD, and OC respectively. M is the midpoint of EF. Find the position vector of M. That means we have to go from O to M. So we'll be going in this direction, 3I, then this direction, 2J, and then this direction, 1K. So the answer should be 3I plus 2J plus K. Okay, part B. Find the angle PAM and we're given a position vector, which is this. Okay, so that means OP is given to us, 1, 1, and 2. Okay, we need the angle PAM, so the angle from P to A to M. So that would be cos theta equals, I could write AP dot AM upon magnitude of AP times magnitude of AM. Okay, now I need AP and AM. So I already have the position vector of P. I already have position vector of A, which is just 3I and 0 and 0. So 3, 0, 0. And we also have OM from the last part, which came out to be 3, 2, and 1. Okay, now let's find AP and AM. So AP would be OP minus OA, which would be, this is OP minus OA. So let's do that directly. That would be minus 2, 1, and 2. That would be AP. Now we find AM. So AM is OM minus OA. So we're subtracting this and this. So again, let's do that directly. That would be 0, 2, and 1. That's AM. All right, now let's substitute that in the formula for cos theta equals -2, 1, 2 dot 0 to 1 upon magnitude of both of these. So magnitude of the first one would be 2 square plus 1 square plus 2 square. That's a 9. Square root of 9 times the magnitude of 0 square plus 2 square plus 1 square inside the square root. That would be a 5. Okay, let's find the dot product. Dot product would be -2 times 0 plus 1 times 2 plus 2 times 1. That is 0 plus 2 plus 2, which is a 4. So we have a 4 over 3 under root 5. Now we take cos inverse of this, either in degrees or in radians. And in degrees, I'm getting this. That's part B. Part C says, find the exact length of the perpendicular from P to the line passing through OM. All right. First, I need the line passing through OM. So, to find the line passing through OM, I will write R. Then I will write the coordinates of M, which are 3, 2, 1. minus lambda or mu lambda, and then I will write O minus M here because we're finding the vector line passing through OM and I've started with M. So in the direction vector spot, I have to write O minus M. O is the origin 0, 0, 0. So that's 0, 0, 0 minus M. And what were the coordinates of M? 3, 2, 1. This would be 3, 2, 1, which gives us R equals 3, 2, 1 minus lambda minus 3 minus 2 minus 1. That's the equation of the vector line. Okay. In fact, I feel like I should have taken the other points. I think I'll take the other points. That will significantly simplify this. What if I take 0 first, the origin first? So that would be R equals O, origin first, minus lambda. And now I'll do M minus O. So M minus O would just be the coordinates of M, which are 3, 2, 1. So this is a lot simpler version. Both will give you the correct final answer, but I'm sticking to this one. So it will be negative lambda 3, 2, 1. Oh, sorry, this was a plus. Why am I writing minus everywhere? This is a plus. That's a plus. This is a plus, and this is a plus. Sorry. Okay, so that's the vector equation for the line passing through OM. Okay. Find the exact length of the perpendicular from P to the line passing through OM. Now, P could be anywhere around that line. Let's make that. So, let's say P is here, and P has coordinates 1, 2. Oh, sorry, that was my kid. Okay, so the coordinates of P are 1, 1, and 2. Okay, and the line is R equals lambda 3, 2, 1. And we need this length. Exact length of the perpendicular from P to the line passing through O and M. Okay, I'm calling this point X. And now we're going to follow those typical steps, which are write down the position vector of P, write down the position vector of X. So OP is 1, 1, 2. OX is the same as the position vector of the line passing through it, which is this. So 3 lambda plus 2 lambda plus lambda. Now we're going to find the vector Px, which is going to be Ox minus OP. So 3 lambda minus 1, 2 lambda minus 1, lambda minus 2. That's Px. Now we're going to take dot product of this Px with this direction and equate it to 0 because they're perpendicular. So Px dot direction 3, 2, 1 equals 0. So it would be 3 lambda minus 1, 2 lambda minus 1, and lambda minus 2 dot 3, 2, 1 equals to 1. So we get a 9 lambda minus 3 plus 4 lambda minus 2 plus lambda minus 2 is equals to, sorry, this was supposed to be a 0, equals to 0. Solve this, you will get 14 lambda here and 7 here. So lambda is equals to half. Now that you have lambda, you can just find the vector px, this vector. So px will be equals to, replace all these lambdas with half. So we get 3 by 2 minus 1, which is a half. And then 2 times half minus 1, that's a 0. And then half minus 2, that would be minus 3 over 2. And we need the exact length of this. So length is the magnitude, which is 0.5 squared plus 0 squared plus whatever this is, 1.5 or negative 1.5 squared. The sign does not make any difference. Okay, enter all of this in the calculator. What do we get? 0.5 squared plus 1.5 squared. That's 5 over 2. So square root of 5 over 2, square root answer. So square root of 5 over 2 simplifies to under root 10 over 2, which is the final answer.